Let's change background just for fun. Ah. Oh. Let's see. Okay. So just some, not so important knowledge here, okay? So any of you guys have seen this picture before?
It's ITB, right, sir?
Well, yeah, sort of. It looks like ITB, but you know where this is? Or this was?
It's either, it's at the front. I forgot the name.
What's it called again? I forgot, man.
No, well, actually, no. Actually, this is the old chemical engineering building. So this building actually was leveled. It was demolished in 1994, I think, 1995. So this used to be our building. Okay, so this is the old chemical engineering building, which is now located somewhere around the electrical engineering now, the STAY. Okay, STAY's building. So STAY Pharmacy is it's about where our old building was located. Okay. So this is yeah, one of the older buildings in ITP, I think. So I think chemical engineering is the second oldest building. I think the first one is obviously the West Hall and East Hall, yeah, Aula Barat and Aula Timur, and this is, I believe, the second oldest. Okay. Yeah, we've we've had a lot of fun and some interesting things going on in this building. Okay. Oh, Pak Wawan, when Pak Wawan went for his school, this building is already gone. So anyway, so this is a very old building, and so the faculty car parking lot is somewhere here, and this is, can you see it? Okay, so this is where the department posts announcements for students. So your exam grade and stuff like that. So it's on this board here. Okay, and these are admin offices. There's some faculty offices here as well in this along this corridor. Okay, so yeah, historic building. Unfortunately, it's actually too small. Actually, the entire complex is quite small and it's not very comfortable. That's why ITB decided to demolish it and replace it with Latex Pulu. Okay, so this was located in an entirely different location. Himatek is somewhere back there, so about maybe about 100 meters that way. So that's Himatek. So the Himatek, the old location of Himatek is opposite from BNI. Okay, BNI now, today's BNI. Okay, all right. All right, so let's begin our class. Oh, Pak Wawan, I don't have screen sharing authority.
Oh yeah, Pak, I will give a permission first.
It's done, it's okay.
I think it's done, Pak, yeah.
Okay. Yeah, okay. Thanks. All right, so before we continue with our discussion, there's an error that we made last week. So this one, actually the unit that was contained in the original version of the class notes was correct. So the number that you have in their older version of your diktat is like 890,000 something, right? So that's correct if the unit is kilojoule per kilomole, but having a unit of kilojoule per kilomole doesn't make any sense because both in kilo and kilo. So it's just the same as saying, okay, this is joule per mole. So a frequently used unit is actually for heating value is kilojoule per mole. Okay, so some people, there's also a mass version of it. So kilojoule per kilogram, for example, or BTU per pound. But kilojoule per kilomole doesn't make any sense. So the number should be like this. So it should be like 890-ish kilojoule per mole. Okay, so this is not kilomole, but actually this is kilojoule per mole. Yeah. All right. So with that out of the way, we can continue with our discussion. And I will not be taking too much time because you will have a quiz later today, and the quiz will be 45 minutes. So it will start at 4:15. Okay, it will start at 4:15. Okay. So just to repeat what we have learned last week. So there are two ways to state or to express heat of combustion. So it's either as a lower heating value or higher heating value. In lower heating value, it is assumed that the water resulting from the combustion is in liquid form, whereas in gaseous form, in vapor form, whereas in higher heating value, the water is assumed to be condensed. Okay. As you condense water vapor into liquid water, of course, you gain additional heat. That's why the heating value is higher if the water is assumed to be in liquid form. Okay, that's it. All right. And the next one, this is a way different approach of calculating or for determining higher heating value. So if we compare it to this one, this is a direct measurement method. Okay, so this is a real number. This is not estimation. Okay, but this one is an estimation. So this is the reason why I write why I use a yellow colored font here, is to highlight the word estimation. So this is not direct measurement, but this is estimation. Okay, so if the fuel composition is known from approximate or from ultimate analysis, okay, then we can estimate. Again, please underline the word estimate. This is an estimation. Okay, so we can estimate the higher heating value using the Dulong formula. Now, this is a very, very well-known formula. You should be familiar with the Dulong formula and how to correctly use it. The Dulong formula states that the HHV, okay, higher heating value, in the unit of megajoule per kilogram is 0.3383, or some resource simply rounded off to 0.34 C plus 1.44 multiplied by H minus O. This is not zero, okay? This is O, okay? O over 8 plus 0.094 S. Now, the quantities C, H, O, and S refers to mass fractions. Okay, again, this is mass fraction, not mass percentages, but mass percent. Okay, do not get confused. Do not put in the wrong numbers, but these are all mass fractions. Okay, again, not mass percentages, but fractions. And of course, you will get weird numbers if you put in the percentages. Okay. All right. Where is my? Oh. There we go. Oops. Move that. There we go. Okay. Yeah. All right. And also the other one is the basis is dry and ash-free basis. Okay, so the C, H, O, and S are mass fractions expressed in dry ash-free basis obtained from ultimate analysis of the fuel. Okay, and if the heating value is required in wet ash included basis, the term for it is as received basis. Jadi basis apa adanya. So as we receive the fuel example, the fuel specimen, we include everything. We include the moisture that is contained by the fuel. We include the ash included in the fuel. So if that's the basis that we require, then we use the formula of this one. Okay. So higher heating value, AR means as received, okay, is equivalent to the higher heating value of dry ash-free basis, which is this one here. Okay, so this one goes here, multiplied by minus over M sub O minus A sub S divided by 100. Okay. Now again, be careful with these numbers. Yeah, even though the C, H, O, and S that you're using in Dulong formula are mass fractions, but if you want to convert the HHV into this as-received basis, the numbers that you put in here, these are mass percentages, not mass fractions. Okay, that's why you see the denominator of 100 here. So M sub O is percent mass of moisture in the fuel, and A sub S is percent mass of ash in the fuel. Okay, so again, these are percent masses, not fractions. Okay, all right. And I think we have discussed this before, so I'm going to skip that. Okay, so now we review several classes of industrial fuels. Yeah, we have here. This is gaseous fuels or vapor fuels. That's liquid fuel, and this is solid fuel. Yeah. So first one, gaseous fuel, and the categories of gaseous fuel is based on origin. So they consist of two major groups: natural gas and synthetic gas. Natural gas is produced by simple separation processes. Okay, of course, inevitably there's some degree of chemical processing in both cases, but in natural gas, the degree of chemical conversion is very minimal. Okay, so they're produced by relatively simple separation processes, whereas synthetic gas involves significant chemical conversion. Okay. General characteristics of gaseous fuels include low C to H ratio, okay, carbon to hydrogen ratio, low heating values, so they're not, they have a low, we call it low energy density. So for a unit mass, for the same unit mass, gaseous fuels contains lower energy. Sorry, for the lower unit volume. Sorry, I have to repeat that. I have to rephrase that. So for the same unit volume, gaseous fuel contains much lower energy compared to liquid fuels, let alone solid fuels, right? They're easy to combust, yeah? And you can easily imagine why, because this is gas. So when you mix gaseous fuels with air, it's very easy to mix. It's very easy to obtain perfect mixture between gaseous fuels and air, because they're both gases. They're all gases. Okay, so gas mixing. The mixing between gases is one of the easiest mixing problem in chemical engineering. Yeah. Clean combustion, and this is the reason for clean combustion is they contain negligible ash, and also they have low C/H ratio. Okay, so the lower the C/H ratio, the cleaner, the easier it is to obtain a complete combustion of that fuel. Okay. Now, let me repeat this in Indonesian. Jadi karakteristik umum dari bahan bakar gas adalah rasio karbon terhadap hidrogennya rendah. Ini menyebabkan pembakarannya menjadi mudah. Ya. Jadi mudah untuk menghasilkan pembakaran tuntas untuk bahan bakar gas karena rasio C per H-nya rendah. Tetapi juga karena rasio C per H-nya rendah, maka heating value-nya juga rendah. So remember from last week's course, okay, the heat of combustion, the elemental heat of combustion, ya, jadi panas pembakaran unsur untuk karbon itu jauh lebih tinggi daripada panas pembakaran unsur hidrogen. Jadi kalau kita punya bahan bakar yang proporsi karbonnya lebih rendah, sudah pasti heating value dari bahan bakar itu akan turun. Ya. Tetapi dengan sisi positifnya adalah semakin mudah dibakar. Ya. Kemudian kadar abunya rendah sekali. Jadi kadar abu dari bahan bakar gas ini bisa diabaikan. The primary minus side of gaseous fuels is they're difficult to store and difficult to transport because they have low energy density. Okay, they're expensive to transport. Yeah, and these are just some examples. So natural gas, which is mostly composed of methane, right? LPG, producer gas, biogas, and water gas. Okay. This is just some interesting examples here. Just the first one there. This is an automobile developed by the Nazi Germany. Okay, this is a Volkswagen Type 181 from the year 1944, and this bulbous thing on the front of the vehicle, this is actually a wood gas producer. So the operator of this vehicle dumps wood into this vessel, and then the wood is heated up at an oxygen-starved condition, so thereby creating what is called a pyrolysis in this chamber. And the pyrolysis produces synthetic gas. It produces gas that is rich in hydrogen and carbon monoxide. Hydrogen and carbon monoxide are combustible gases. So the gases produced by the pyrolysis of the wood is then injected into the engine in the back. So the engine is in the back. This one is not the engine, but this is the gasifier. Okay. Okay, and the bottom one, the bottom picture, this is a biogas reactor or biogas digester that was being installed by Himatek in one of their desa binaan. Okay. Okay, natural gas, of course, I believe most of you are already familiar with what natural gas is. Okay. Range of composition, natural gas consists mostly of methane from 70 to 96%. Some ethane and also propane, and relatively little, I'm sorry about this typo, it should be relatively little heavier compounds or heavier hydrocarbons. So from C4, okay, butane isomers, and also C5, so from C4, C5, C6, all the way to C10 or something. So we call those components condensates, okay? Not to be confused with steam condensate. Okay, so the term condensate in oil and gas business refers to this one here, okay? Propane, butane, pentane, and C6 plus, okay? The heavier liquid hydrocarbon. Yep. Now, natural gas is a favorable industrial fuel because it has a clean burning image, okay? So it's good for environmental image of the company. However, actually, it's not a very efficient fuel. Okay, so thermal generation efficiency is actually rather low because of their high hydrogen content. So the thermal efficiency of natural gas burning system is only usually about 23%. Okay, and this is, of course, well, you know all of this, right? This is the newest discovered natural gas field in Indonesia, which is located right at the border of Indonesia and Australia. Okay, and in fact, it's the closest place that can process this gas is actually not in Indonesia, but here in Darwin. So Darwin is somewhere here. Okay, but of course we cannot do that. So we have to somehow build a pipeline from Abadi gas field all the way to southern Maluku, somewhere there. Okay. So anyway, this project is still on hold. I think right now we're not sure about how things are progressing with Abadi gas field. Okay, how do we transport natural gas? Okay, so there are several modes to transport natural gas. It can be transferred into pipeline through pipelines. It can be compressed like this. Okay, so this is this is the compressed natural gas depot in Plumpang in Jakarta, just an example. So in this mode, the natural gas is compressed to pressures, to very high pressure, like around 250 to 300 bars, okay, and as a gas form, in the form of gas, okay. And of course, we can always transport natural gas as liquefied natural gas. But because natural gas liquefaction happens at minus 160 degrees Celsius, then the storage tank for LNG has to be cryogenically insulated, okay, because the condition inside is extremely cold, okay, minus 160 degrees Celsius. Okay. Now, when we liquefy natural gas, then the energy density increases tremendously. Okay, so LNG is actually much more economical to store and transport, especially if the demand is large. Yeah. So one cubic meter of LNG contains the same energy as 600 cubic meter of gaseous natural gas. Okay. This is a pretty neat example. This is small scale, actually micro scale transportation of LNG that is being done in China. So they transport these trucks that contains liquefied natural gas. Remember, this is LNG. This is not gaseous natural gas like that, but this is all liquefied. So this is cryogenic tank. Okay, so the LNG is put in small tanker trucks like this, and then the tanker truck is loaded onto a ferry boat. Okay, kapal ferry. We don't have this kind of system yet in Indonesia. Okay, so we're still relying on our LNG tanks is directly installed on the ships, on the boats. Okay, not on trucks like this. Okay. Again, some knowledge on how we transport LNG. Okay, there are several modes to transport LNG. Okay, so if this is the LNG plant, for example, like in PT Badak or Donggi and Tangguh. Okay, so from LNG plant, the LNG can be offloaded into or can be loaded into LNG tankers like this one. Okay, so this is a conventional LNG tanker. And then the LNG tanker goes to the receiving terminal. Now, there are several ways how we can do this. So, for example, here, let's see what else. FSRU, okay, floating storage and regasification unit. That's what FSRU is. So, if the customer wants the LNG to be delivered by FSRU, then what happens is this LNG tankers then unloads its liquid LNG into these FSRU. Okay, and on top of these FSRU units, then the LNG is regasified, and the gaseous LNG, the gaseous natural gas, is then transferred onshore to its point of use, power plants, everything. Okay, or the LNG can be transferred in liquid form into receiving terminals like this. Okay. Yet another option is to produce the LNG on ships. We call it FLNG, okay? Floating liquefied natural gas. So these will be floating natural gas liquefaction plants. It is tethered on gas fields like this. So this is actually a floating LNG plant. Sorry about that. 1 second. Okay, sorry about the interruption. Sales. Okay. second. Let me get this properly aligned first. Share. Yep. Okay. So we have floating LNG. We have where are you? And so there are several ways by which we can produce and transport LNG. Yeah. And as LNG production becomes smaller and smaller in terms of scale of production, these alternative technologies such as FSRU and FLNG becomes more and more feasible. Okay. Right. You can skip. I can skip this, and I can probably just highlight some of the components here. Okay. So from methane, ethylene, ethane. Okay. So these would be the components of what we call in our everyday lives as LNG or natural gas. Okay. So in industrial term, natural gas usually refers to mixtures of methane, ethylene, and ethane, and a little bit of perhaps C3 and C4. Okay. Now, the next fraction, okay, from C3 to let's say C5, okay, so from propylene, propane, butane, butane, and isopentane, these are LPGs, liquefied petroleum gases. Okay. And anything from C4 onwards, from C4, C5, C6, C7, and so on, we call those condensate. Yep. Okay. So again, this is natural gas or LNG. Okay, LPG is here, and the rest are these are condensates, kondensat. Ya. Jadi kalau kita bilang LNG itu isinya apa? LNG isinya adalah ini kira-kira, ya, metan, kemudian etana, etilen, dan seterusnya. Mungkin sedikit ada propana, ya. Sementara LPG, so this would be the stuff that we use every day in our kitchen, ya, bahan bakar dapur, ya. So LPG contains propana, propena, isobutana, isobutan, dan sebagainya. Jadi senyawa-senyawa hidrokarbon dengan 3 atom karbon dan 4 atom karbon. Yeah. So those would be the LPG. Yeah. Yep, there you go. So this is liquefied petroleum gas or LPG. And the main difference between LPG and LNG is that an LPG can be liquefied at ambient temperature at moderate pressures. Only 3 to 9 atmospheres is enough to liquefy petroleum gas. Okay. Methane, on the other hand, requires cryogenic temperature, minus 160 degrees Celsius. Here, you can liquefy at room temperature at slightly high pressure. Okay. And the reason of this is because the difference in the thermodynamic properties. Okay, and the difference between the PVT, the pressure, volume, temperature properties between methane, ethane, propane, and so on. Okay, so the difference is such that we can liquefy propane and butane at room temperature and at slightly high pressure. 3 to 9 atm is enough to liquefy propane, butane, and also pentane. Yeah. But if we talk about methane and ethane, okay, it doesn't matter how much pressure you apply, you cannot liquefy those gases unless you're cooling them down to cryogenic temperature. Okay, this is because the value of the critical pressure, critical temperature of those components. Yeah. So go back to your thermal class. Yeah. Okay, and this is the reason why LPG is so popular for our everyday fuel, for consumer grade fuels. Ya, jadi ini kenapa LPG itu sangat populer sebagai bahan bakar untuk konsumen sehari-hari, untuk rumah tangga, karena produksinya mudah sekali. Ya. Karena LPG ini bisa diproduksi, bisa dicairkan pada temperatur ambient dan pada tekanan rendah. Hanya 3-9 atmosfer, ini mudah sekali. Ini mudah sekali dicapai dengan kompresor yang konvensional. Ya. Makanya dia sangat populer untuk bahan bakar sehari-hari. Okay. But the problem with LPG is not in the production itself, The problem is the scarcity of resource. Ya, jadi bikin LPG itu gampang, tetapi yang susah adalah mencari sumber LPG. Jadi LPG itu sebetulnya adalah fraksi yang konsentrasinya kecil sekali di alam ini. Ya, jadi kalau kita lihat fluida yang keluar dari sumur gas, itu sebetulnya komponen C3C4 itu konsentrasinya dikit. Karena itu LPG biasanya dihasilkan dari sebagai byproduct proses penghilangan minyak bumi. Okay? So LPG is mostly produced as byproduct from the refining of crude oil. Okay, so LPG is because LPG in nature is scarce, langka. Yeah, so most LPG is produced synthetically in oil refineries and petroleum refineries. Yeah. Okay. Yeah, next one is biogas. Okay, so biogas is produced by the decomposition of vegetable and animal biomass. Of course, the composition of biogas is mostly methane, about 40 to 70% methane. Quite a lot of CO2. That's why the heating value of biogas is actually not that great, but it's enough for daily use, okay, for household use. And okay, this is enjing gondok. Okay. The English term for enjing gondok is water hyacinth. Okay, and water hyacinth is actually an excellent source of biogas. Okay, and that's not chicken. That's chicken. Okay. Human manure, human manure is actually a poor source of biogas. Okay, that's why we very rarely use human excrement to produce biogas. All right. So you can take a look at these graphs just for fun later on, but you know, this is a small scale biogas plant. This would be the one that's installed by Himatek in their Desa Binaan, okay. But this one is a large scale biogas plant in Denmark, okay. So the reason why we don't have large scale biogas production in Indonesia yet is because small plants like this, okay, in small biogas plants like this, the rate of production is highly uncontrollable. So anytime you dump in, as you dump in the biogas sources there, okay, animal manure, plant, and so on, so the digesting process will start, and this it's very difficult to determine when you will get the gas, okay. And more often than not, the gas is produced when nobody needs it. Okay. And because this is a very simple setup, ini teknologi tepat guna gitu ya. So these units typically don't have a good storage volume for the produced gas. It has to be consumed right away as it is being produced. Okay. So this is the reason why such biogas production only works in the villages. Yeah, where you have people attending their homes almost on a 24-hour basis. That's why they can adjust their daily activity. For example, this household, ibu rumah tangga. So she's timing her cooking. She's timing her cooking work based on the availability of the gas. Ya, jadi ibu rumah tangga ini menyesuaikan kapan dia memasak itu adalah pada saat gasnya sudah tersedia, and then can she cook. So she cannot just turn on the stove and expect that gas will be produced anytime that she wants. It has to match with when the biogas plant is ready to produce the gas, and this is the main drawback of small-scale biogas production. It's very difficult to time it. Jadi mentimingnya susah sekali untuk produksi gas yang berskala kecil begini. Ya. Okay, so we're moving on to liquid fuels. I have, what time do I have? Oh no, I still have about half an hour. Okay. Okay, liquid fuel is they have intermediate C/H ratio. Okay, storage and transportation are easy and inexpensive. Okay. For lighter fuels, the combustion is clean. But for heavy fuel, the combustion requires preheating because liquid fuel can also be very, very viscous. Yeah. Ash content is from low to medium, and the heating value is again also medium. Yeah. Some parameters that you should be aware of. Okay, at least you should be aware of these terms. Okay, API gravity, condensation carbon, sulfur content, basic water and sediment, basic sediment and water (BSW). Okay, viscosity, pour point, cloud point, and flash point. Okay, this is an additional reading that you can browse with regard to these specifications. Okay, so I highly encourage you to take a look at this link that I'm provided. Yep, and these are the industrial liquid fuels. Okay, so industrial petroleum-based liquid fuels include fuel oil. Yeah. There's no Indonesian term for it, so you cannot say minyak bakar. Okay, that's not we don't have the proper Indonesian translation for it. So Indonesians also say fuel oil. Ya, jadi kita dalam istilah perdagangan dan perniagaan di Indonesia ya namanya fuel oil. Kita tidak terjemahkan menjadi minyak bakar, gitu ya. Right. So there are several grades of fuel oil. We have light fuel oil, medium fuel oil. Sometimes Pertamina, in Pertamina's term, MFO is not medium fuel oil, but marine fuel oil. We have HFO or heavy fuel oil. IDO is industrial diesel oil. Okay. HSD is high-speed diesel engine. Okay. Now, there is a difference between IDO and HSD. Yeah. The diesel fuel that you use, that people use in vehicles, in motor vehicles, like trucks and buses, those are HSD. So HSD stands for high-speed diesel. Okay. Let me go back to presentation mode. Yep. There we go. Okay. Yeah. So HSD, this stands for high speed. Hey, sorry about my handwriting. High speed diesel. And this one stands for industrial diesel oil. Okay, so high-speed diesel, this is the fuel that we use in vehicles, okay, in diesel vehicles, trucks and buses and so on, okay. Isuzu Panther, Innova Diesel and everything. So those are run on HSD, high-speed diesel. High-speed means not the vehicle, but the engine speed. So the RPM of the engine is above a certain level. I think it's 1,000 RPM. Okay, so if the engine rotates at higher than 1,000 RPM, then it is regarded as a high-speed engine. Okay, and the fuel that is suitable for high-speed diesel engine is called HSD fuel. Yeah, IDO fuel is heavier. It has higher viscosity than HSD, and industrial diesel oil is used in industrial diesel engines. So things like the large diesel engines that is used for PLTD, pembangkit listrik tenaga diesel, for example, or marine vessels, kapal-kapal laut. Those engines use IDO. Okay. Okay, and here are some specifications of the different classes of fuel oil. So take a look at those at your own leisure and later on. Okay. All right. Let's see if I can highlight some stuff here. Okay, here we go. Take a look at these sulfur content and then ash content, okay, and C/H ratio. Okay, so the sulfur content going from lighter to heavier fuel, okay, the sulfur content, sorry, this would be 1.35, okay, the sulfur content increases going from lighter liquid fuel to heavier liquid fuel. Jadi kalau kita membandingkan bahan bakar cair yang encer, ya, yang fluid, ya, yang viskositasnya rendah, dengan yang kental, yang viskositasnya tinggi, itu biasanya sulfurnya naik. Demikian pula dengan kandungan abunya. Ya. So not only the sulfur, but the ash content also increases that way. Dan peningkatan kekentalan, peningkatan viskositas itu pertanda bahwa rasio karbon terhadap hidrogennya naik. Ya. Dari fuel oil yang paling ringan sampai fuel oil yang paling berat. Gitu, ya. So much so that heavier fuel oil requires heating because it looks something like that. It looks like gel. Okay, this is what a heavy fuel oil looks like at room temperature. Okay, so before you can combust this, you need to heat it up. Okay, you need to heat it up in order to give it a better fluidity. Ya, jadi bahan bakar cair yang berat-berat seperti MFO apalagi HFO itu tidak bisa digunakan secara langsung, tetapi harus dipanaskan dulu supaya encer, ya, supaya viskositas rendah, baru kemudian dia bisa disemprotkan ke dalam mesin. Nah. Okay, and these are some correlations between the physical properties of the different fuels. Yeah. Okay, this is heating value. That's correlation between density, which is specific gravity, with API gravity. Sorry about that. Okay. And it's quite useful. I would say this is not really absolutely critical for the class, but it's quite useful for you if you. Geez, this is giving me a hard time. Sorry about this. So it's actually quite useful for you to understand these terms. Okay, so there's a term called API gravity, yeah, specific gravity. Both of these quantities expresses the density of liquid fuels, but API density is defined such that lighter fuels, okay, lighter fuels will have higher API density number, okay? Whereas, of course, as we all know intuitively, heavier fuel will have heavier specific gravity. Okay, so be careful when you want to express fuel density. Make sure which density are you talking about? Are you referring to specific gravity or are you referring to API gravity? API is American Petroleum Institute. Ya. Jadi ini bukan sesuatu yang kritis-kritis banget gitu ya, tapi ada baiknya kalau kalian tahu sedikit-sedikit tentang istilah ini ya. API gravity ini adalah cara menyatakan densitas bahan bakar cair menggunakan standar API. API adalah American Petroleum Institute. Ya. API gravity ini definisinya sedemikian sehingga kalau angkanya naik, ya kalau angkanya naik, itu justru bahan bakarnya lebih ringan. Ya. Sementara kalau specific gravity ya ini seperti yang kalian ketahui dari tingkat 1 ya. Semakin tinggi specific gravity ya semakin berat cairannya gitu ya. Okay. So for example, just to give an example, a crude oil with an API gravity of, let's say, 12 or 15, somewhere here. Okay, so a crude oil with that API gravity is considered to be a heavy crude oil. Just to give you an example. Yeah. So be careful when dealing with these gravity numbers. Yeah, densitas. This one is viscosity to density correlation. Yeah. That's kinematic viscosity. So this would be the viscosity that you learn from your PTK class or from your proses perpindahan, peristiwa perpindahan, okay, viscositas kinematik as a function of temperature. So of course, all fuels, all liquid fuels, the viscosity will decrease as you heat them up. That's a no-brainer. Ya. Jadi bahan bakar cair apapun, itu viskositasnya pasti berkurang kalau kita panaskan. Ya. And going from lower left hand side to upper right hand side, the density increases. Yeah. So this is gasoline. The bottom one is gasoline. Yeah. Minyak bahan bakar premium, Pertamax. So those are gasolines. Okay. And then we have JP4. JP4 is JP stands for jet propulsion. Okay. So this is jet fuel. Yeah. So jet fuel is roughly equivalent to kerosene, minyak tanah. Okay. So just because jet engine sounds fancy doesn't mean that their fuel has higher octane number than our automobile fuel. Quite the contrary, actually, in terms of hydrocarbon grade, actually, jet engine runs on lower quality fuel than our car, than our everyday car. Okay, so their jet fuel is roughly equivalent to kerosene or minyak tanah. And then we have the fuel oils, the FOs, okay, number 1, FO, number 2, FO, and so on. Up to the heaviest one, number 6 fuel oil. This is a very, very heavy fuel oil. Okay. Viscosity determines the ease by which fuel is pumped and vaporized in combustion chamber. Okay. Atomized, this is a somewhat leading term. This is the term that is frequently used by our friends in mechanical engineering department. Okay. This is actually not a very accurate term because you don't strip down, you don't dissociate a hydrocarbon molecule into their atoms in a combustion system. What you do is simply vaporize them, and that's enough. Okay. So atomizing is a somewhat misleading term. Okay. You don't atomize. Okay. You don't convert them into atoms. You simply vaporize them. Okay. All right. Yeah, going back to these visual examples. So this is what our everyday bahan bakar solar, okay, that we see in SPBUs. Okay. It looks something like this at room temperature. So these are called HSDs, high speed diesel. Biodiesel also belongs to HSD, high speed diesel fuel. Okay. And this one, naphtha is roughly equivalent to gasoline, Pertamax, premium, what do you call it, Pertalite. So those are all naphtha fuels. Okay, number 2 fuel oil is heavier. Okay, so if you look at the consistency, this is probably something like cooking oil, perhaps. So it's thicker than gasoline. So this one is probably looks something like like CPO, seperti minyak kelapa. Okay. And number 6 fuel oil, this is a very heavy, this is a very thick. This actually flows like honey. Ini seperti madu ini konsistensinya. Ya. So the viscosity looks something like honey. So when we're dealing with MFO or HFO, we need to have a preheater like this. Yeah, it usually runs on electric power. So for example, in large vessels, di kapal laut yang besar-besar, kapal tanker, kapal perang misalkan ya, that runs on MFO, then they typically have these electrical preheaters to preheat the fuel before it can be injected to the engine. Yeah. Okay, we can talk about this very quickly. Non-petroleum liquid fuels. Okay, so this would be alternative fuels. Okay, the one that is not derived from petroleum. The first one is tar sand, not Tarzan in the movie. Okay, tar sand. Okay, what do you call it? Some people call it bitumen. Yeah, pasir bitumen. Yeah. So bitumen sand are naturally occurring type of sand that contains heavy hydrocarbon, yeah, asphalt. Yeah. This is a picture of Buton natural asphalt mining. So this is in the island of Buton in Maluku. Okay. I think up to now, I think Buton is the only place in Indonesia that has been identified as having a natural asphalt deposit. And actually, the natural Buton asphalt has been utilized since the Dutch colonial era. Okay, and it's still there now. It has not been depleted yet because it has no other use. Okay, it's too heavy. It's too heavy to be extracted as crude oil. Plus, we still have enough deposit of or enough reserve of fuel of crude oil that we're not that desperate yet to utilize Buton tar sand as a liquid fuel. Not yet. Okay, we might be there in a few decades, but for now, it's not economical yet to utilize hydrocarbon contained in this Buton natural asphalt as a source for liquid hydrocarbon. Okay, so for now we only use it for pavement asphalt. Yeah. The second one is coal-derived oil. Ya, jadi minyak yang disintesis dari batu bara. Okay, so this can be produced by gasification, pyrolysis, or liquefaction, or hydrogenation of coal. Okay. So several process routes are available. You can read about those process routes in Paris Chemical Engineering Handbook. Okay. For example, you guys might have heard of, especially if you work in Lab TRK, you might have heard the term Fischer-Tropsch technology. Okay. Fischer-Tropsch. Okay, so Fischer-Tropsch actually is an old process. It has been around since World War II, and basically this process converts coal or other solid fuel into liquid fuel. Okay, of course it's not as easy as it sounds. This is the reason why Fischer-Tropsch technology is still being developed even today. Okay, so this is not a mature process technology yet. And then we have these also interesting category of non-petroleum liquid fuels, right? So we have alcohols, yeah, including methanol and ethanol, okay? And this includes bioethanol, yeah. And however, because these fuels tend to be expensive, okay? So alcohols, this tends to be, yeah, expensive. Okay, so that's why it's rarely, very, very rarely used for process industry. Usually alcohols are used for consumer fuel, ya, sebagai bahan bakar konsumen. Langsung dijual ke masyarakat sebagai bahan bakar untuk kendaraan bermotor. Ya. And even in Brazil, as a note, Brazil is the largest bioethanol producing country. Yeah. Even in Brazil, they don't use bioethanol for industrial fuel. Okay, it's used for consumer grade fuel. Biodiesel, however, is more feasible for process industry, even though biodiesel is not yet used as primary fuel yet, but it has been used as supplementary fuel for industry. Okay, and it has been used actually as a blending component for IDO and Hsd. Okay, and the objective of adding biodiesel, I think Indonesia now is it's going to this B30 level. B30 is a code for industrial and commercial diesel fuel that contains 30% biodiesel. And the objective of doing this is, of course, to reduce greenhouse gas emissions, right? Because biodiesel is more environmentally friendly compared to petroleum diesel, of course. Yeah. Okay. Any questions here?
Sir, I'd like to ask.
Yep. Mm-hmm.
From our class, which is petroleum and natural gas upstream processes, there's this one source that actually piqued my interest, which is shale oil. And is it a non-petroleum one or is it a petroleum one? Because I'm a bit confused. It was taught in petroleum class.
Ah, okay. Shale oil, yeah, this one. Yeah. This is where things get blurry. Okay. Hopefully I'm not misleading you guys. As far as geological origin is concerned, okay, let me write this down here. So this is typically when people differentiate between petroleum and non-petroleum hydrocarbons, we talk about their geological origins. Geological origins. Okay, so yeah, in the sense of geological origins, shale oil is actually petroleum. Okay, because it originates from planktons and animal matter. Okay, so okay, here we go. Let me just make a doodle there. So petroleum is originates from planktons and animal. Whereas coal originates from plant matter. Okay. And there's something in between. I think let's see, algae is also included here. I think so. Algae also produces petroleum, not coal. So coal, what do you call it? To be more precise, this is multi-cellular plants. Multi-cellular plants. Okay. So single cell plants belong to petroleum, or they produce petroleum, but multicellular plants, this would be, like trees, grasses, shrubs, things like that. So those ferns, okay, those produce coal. Ya, jadi petroleum ini asalnya adalah dari tanaman-tanaman bersel tunggal, planktons, kemudian algae, ya, algae yang bersel tunggal, kemudian animal, binatang. Itu yang akan menghasilkan kemudian fosil dari makhluk-makhluk ini yang kemudian menghasilkan petroleum. Untuk batu bara, coal, asalnya adalah dari tanaman multiseluler, jadi tanaman-tanaman yang besar, pohon, pakis, semak-semak, itu yang kemudian menjadi batu bara. Now, shale oil actually belongs to this one. Yeah, so shale oil contains hydrocarbon that originates from this category of lives. Ya, jadi makhluk hidup yang menghasilkan shale oil itu kategorinya masuk ke sini. So shale oil is by definition petroleum. Okay. However, this one is different though. Here we go. CBM. Anybody have heard of this?
Me personally, no. I haven't.
CBM is coal bed methane. So decomposition processes, these complex reactions that occurs in a coal deposit, sometimes produce methane, yeah, which is trapped inside the coal seam. Yeah. So CBM, even though it's methane, is actually produced by plant matter, by this one here, okay, by this one. Yeah, so this is different from shale gas. There's shale oil and there's also shale gas. So shale gas it usually occurs alongside the shale oil. CBM, coalbed methane, occurs alongside coal. Yeah. So where is the put-on natural asphalt fall into? So they fall into this category. So put-on natural asphalt is closer to shale oil. Okay. I hope that clears your questions. Any other questions? Yeah. Okay. Yeah, it's been a big issue now, and it's actually the shale oil is actually the source of oil trade wars, especially within two big countries, the US and Saudi Arabia. So if you guys read the history of what happened several years ago, where crude oil plummets, price plummets around the world, this is because, well, previously the United States of America relies on imported crude from Saudi Arabia, right? Saudi Aramco. That's there's a huge company. So now, and several years, I think maybe between 10 to 15 years ago, the US started to find shale gas and shale oil reserves, huge reserves in the US. Okay, so and they then developed technology to economically recover shale oil and shale gas from their vast resources of reserves of shale oil and gas. So to the point where they no longer need imported crude from Saudi Arabia. Okay, so they drastically reduce their import of crude from Saudi Arabia, and the Saudis got angry, and they because their income was reduced because the US reduced their demand of Saudi oil, and the Saudi then ramps up production because they need to preserve their income, right? So this starts a whole global chain of events where countries around the world race to produce more and more oil, Russia including. Okay, Indonesia didn't join the race because we don't have much oil to begin with, and the global effect is this this reduction of oil price. Okay, because everybody's rushing to produce more oil, because the single biggest oil market in the world, which is the US, starts to reduce their oil import. Yeah, so that started the whole incident of global crash in crude oil pricing. Yeah, and that's also have an effect in our biodiesel, because we one of the biggest motivation in the development of biodiesel in Indonesia is, of course, because we want to be less reliant on fossil fuel, which at the time was at an all-time high price. But then after these trade wars between Saudi Arabia and the US, then suddenly, well, biodiesel is not so economical anymore. So now our main motivation for producing biodiesel is not economics, but environment, this one. Okay. All right. Well, yeah, that's life. That's economics. That's oil and gas economics for you. Okay, solid fuels, 5 more minutes. Okay, I think I have mentioned this last week. So solid fuels have high carbon to hydrogen ratio, so they have a very high energy density. Okay, but they're difficult to ignite. Okay, often they require the presence of liquid fuel to be ignited. Okay, combustion tends to be dirty, and they contain a lot of ash. Jadi kadar abunya tinggi, kemudian karena kadar karbonnya tinggi, maka pembakaran dari bahan bakar padat ini juga cenderung kotor. Artinya banyak menghasilkan jelaga. They produce a lot of soot or unburned carbon. So soot is particles of unburned carbon. Yeah, but because they're solid, they're easy and safe to store and transport. Like this. Now you can transport coal like this, from Kalimantan all the way to Java safely, economically. You don't care if it got rain on. It doesn't absorb that much moisture anyway. So all you have to do is just drag this barge containing several tons of coals to Java and just dump it as you arrive in Java. Go back to Kalimantan, okay, and very easy. It's very easy. It's very cheap to transport. You don't need a special tanks. Tidak perlu tangki khusus untuk mentransportasikan batu bara. A barge is enough. Barge, coal barge. Okay. Barge. Ya. Tongkang batu bara. The Indonesian word for it is tongkang. This one is also important for solid fuels. Because they're difficult to ignite, then you have to grind it down. You have to mill it. You have to reduce the particle size before it can be combusted. Yeah. Okay. And these are the specification parameters of the solid fuels. You can read about it on your own. This one is an interesting. This is a waste fuel. Actually, this is I'm not really sure what this is. I think this is some sort of agricultural waste. So this is probably rice husk. This looks like rice husk or sekam padi. Yeah, this looks like rice husk. Hopefully, I'm not mistaken. Okay. So rice husk is a pretty promising. Is it? Wait. Let me. I think I wrote down something down there. Nope. Okay. So rice husk is quite promising in Indonesia because they're present abundantly. Okay. However, nothing is as easy as it seems when it comes to waste-derived fuels, because burning rice husk is actually not an easy task. It contains a lot of silica, so the ashes tends to be abrasive and so on. So the bottom line is, it's not always easy to combust solid waste into energy. Okay. Now you might heard of some people doing energy from municipal waste, dari sampah kota. Yeah. It's from this one here, municipal waste. It's a good concept, but actually it has a lot of practical hurdles. Ya, jadi kendala praktis untuk membakar sampah kota menjadi energi itu banyak. Ya. Especially in country like Indonesia, where we don't have a good waste management system. Yeah, so everything is mixed. Plastics is mixed with organic waste, mixed with paper, mixed with tas kresek and so on. So the most fundamental problem in Indonesian waste management is waste sorting, pensortiran sampah, ya, garbage sorting. You cannot really burn plastics. Okay. Now you might have read somewhere, maybe in newspaper or in TV, where people convert plastic into fuel. Okay, it actually has to be done in a very, very well-controlled manner, because most plastics contains chlorine, yeah, PVC, for example, polyvinyl chloride, and chlorine. If you burn plastic that contains chlorine, because chlorine is an oxygen scavenger, so actually chlorine retards the combustion process. Jadi klor di dalam PVC itu memperlambat proses pembakaran, resulting in nasty stuff like dioxins. Okay, so let me write down the name of that compound. Dioxins. Dioxins are toxic gas, and it results from the combustion from the retarded combustion of polymers or from heavy hydrocarbons that contains elements like chlorine, bromine, and things like that. Okay, so and so actually it's not really not that easy at all to combust plastics. Okay. Now I'm going to end our discussion today on coal. Of course, coal is the most abundant solid fuel now in Indonesia. Okay. There are several classifications of coal based on their geological age. We call those ranks. Ranking batubara, yeah, coal rank. The youngest one is lignite. This is also called brown coal because the color is brown. Yeah. The second oldest is subbituminous, and then bituminous and semi-bituminous. And the oldest one, the geologically oldest coal is anthracite. Okay, so going from top to bottom, the C/H increases with all its consequence. Okay, so as you so going from top to bottom, because the C/H increases, the heating value increases, but the ignitability decreases. So it's getting more and more difficult to ignite, going from lignite to anthracite. And actually, people do not use anthracite as fuel. So this is generally not regarded as fuel. But it is typically regarded as source of carbon for chemical reactions. For example, you want to reduce metal ores into elemental metals, then anthracite can be used as reducing agent. They're not regarded as fuels. Yeah. Indonesian coals, typical Indonesian coals belong to these two categories, two ranks, either lignite or subbituminous. There are some bituminous coal resources in Indonesia, but they're quite scarce. So most Indonesian coals belong to lignite or subbituminous. Ya. Jadi sekali lagi kalau dikatakan apakah Indonesia kaya batu bara? Ya lumayan. Okay. We're not the country with the biggest resource. Ya lumayan, kandungan batu bara kita cukup banyak cadangannya, but their rank is typically low. Yeah. So the energy quality is not that good actually. Indonesian coals, they don't contain as much energy as, let's say, Chinese coals, for example. Yeah. However, the advantage of Indonesian coals is our coal typically contains low sulfur, okay, compared to Chinese coals. Yeah. Okay. So with that, does anybody have one or two questions before we go to the quiz? Okay, if not, Pak Hendra or Pak Wawan can take over for the quiz. Thank you very much for your attention.
Yeah, Pak Miki, thank you for the opportunity. So I would like to explain just brief explanations regarding the implementations of today's quiz. Yeah. So for today's quiz, it will be conducted through the EduNext. Yeah. So I have uploaded the questions. It only consists 2 questions. Yeah. So the quiz instructions is actually given, yeah, in the question sheet, yeah, and also I put it also in the EduNext. So please have a read through it, yeah. And the quiz durations will be 45 minutes. I will extend the durations because previously I set up until 5 p.m., but I will add 5 more minutes, yeah, until 5:05. And then after you finish answer all of the questions, you can just submit it through the EduNext here with the proper format file name, quiz01_your_student_ID. Okay, so it's 45 minutes until 5:05. You can start from now. So the quiz is actually individual, yeah. So please do not cooperate with other students. And one of the questions, 1 out of 2 questions is actually I put it kind of specific for 2 students, yeah, for each type of the questions, yeah. Please have a read carefully through the questions, and please do it based on your student ID, especially for number 1. But for number 2, all of the question is actually the same. And I would like to remind you that the quiz is actually open book, so you can open the book, open internet, open all of the sources that you have, so it's it's open book and open all source.